In this lecture, we shall consider some more advanced level problems on motion in 2 dimensions. Problems on both projectile motion and circular motion will be considered. As before, we shall further classify the problems in grades 1, 2 and 3 depending on their difficulty level. So let us go for the first problem in the lecture, which tells that a boy stands in front of a smooth vertical wall and throws an elastic ball towards it with speed 21.2 meters per second at 45 degrees above the horizontal. At the time of leaving the hand, the ball is at a distance of 5 meters from the wall and 1.80 meters above the ground. How far behind the boy will the ball strike the floor? A typical question in projectile motion. Let us first understand it with the help of a figure. We shall put this problem in difficulty level 2. Here is the horizontal floor and the vertical smooth wall you can see. And suppose the boy is initially standing at this position with his face towards the wall. He is throwing a ball with an initial velocity vector u, shown by this blue arrow. We have been given in the problem that magnitude of initial velocity is 21.2 meters per second. Further, the angle made by this velocity vector u with the horizontal, that is 45 degrees, is further given that ball at the point of projection is at a height of 1.80 meters above the ground and at a horizontal distance of 5.00 meters from the wall. Let me take this point to be the point A, that is the point of projection of the ball from the hand of the boy. After the ball is thrown, it follows the parabolic trajectory of a projectile and hits the vertical wall, say at the point B. It rebounds from the wall and then follows some other parabolic trajectory, also of a projectile, to eventually hit the ground at the point C behind the boy. We are supposed to find out location of this point C with respect to this boy. That is the question here. So first of all, let us go for a quick choice of our coordinate system. We take the origin of the coordinate system to be at the meeting point of the floor with the wall. Our plus x axis is pointing horizontally to the right along the floor, that is the plus x axis, and our y axis is pointing vertically upwards along the wall. So with this choice of coordinate system, the motion of this ball remains confined in the xy vertical plane and eventually it hits the floor at this point. During the motion of the ball, we ignore air resistance. Therefore, it's a freely falling body and the only acceleration possessed by the ball during its flight is acceleration due to gravity g pointing downwards. With this understanding, let us write down here that at time t is equal to 0, that is the time at which the ball is projected from the hand, this point A has got its coordinates x0, y0, where x0 is equal to 5.00 meter. Look at the figure and confirm this. Y0, the initial position coordinate, y coordinate, that is of the ball at the moment of being released from the hand, that is 1.80 meter. We have chosen our origin at this point, therefore this distance and this distance, they come in the coordinates of the point A. Also, looking at the figure, you can see since the initial velocity vector is making angle of 45 degrees with the horizontal, therefore I might resolve u into its two components. I don't want to show this resolution, you can show it yourself, and we can write down the x component of initial velocity vector ux, that is pointing leftwards horizontally, that is in minus x direction, Therefore, by my sign convention, this is minus u into cos theta. Well, in this case, it is minus, the value of u is given to be 21.2 meter per second, and here the angle is 45 degree. Therefore, this is coming out to be minus 15.0 meter per second. Once again, negative value of x component because this is pointing leftwards in the minus x direction. Similarly, you can find out the y component of initial velocity vector is pointing vertically upwards in plus y direction, therefore positive, and given by the formula u sine theta. Well, I'm calling this angle 45 degree, that is angle theta, of course. So this is u sine theta, and this is coming out to be 21.2 meter per second into sine 45 degree. It is also same as cos 45, 1 upon root 2. So this is coming out to be plus 15 meter per second. These are the initial velocity components of the ball at the point of release from the hand. Let us now consider the motion of the ball between the point A and the point B, where it hits this wall. So we are considering the projectile motion of the ball from A to B. And since the motion taking place in a xy plane, as with typical projectile motion problems, we can consider the x motion and y motion separately. Let us consider the x motion of the ball between A and B. We apply this formula: the final position coordinate x is equal to initial position coordinate x0 plus x component of initial velocity into time of travel plus half into x component of acceleration into time squared. Now, as you can see, the point B is lying on the y-axis, therefore the x coordinate of the point B is 0. So you can write down that finally at point B, over this part of motion AB, position coordinate becomes 0 finally. Initially x0 listed above 5.00 meter plus ux, that was minus 15.0 meter per second into time of travel. And since the motion doesn't have any acceleration component in horizontal direction, is only vertical, therefore this ax term is 0, and this whole thing is coming out to be 0 only. So you have got the equation: 0 is equal to 5 meter minus 50 meter per second into t, and solve from here to show that time of flight of the ball between the points A and B, that is coming out to be 0.333 second in 3 significant figures. Now once we get the time of flight from A to B, we can find out the y coordinate of this point B also. So we consider now the y motion of the ball between the 2 points, and the final y coordinate is given by initial y coordinate y0 plus ey into t plus half into ay into t square. This is equal to, well, y0 is equal to 1.80 meter, already listed earlier, the initial y coordinate of this ball at the time of throw.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.